Yeah, so our first problem is like combination sum, and we are given an array of distinct integers, candidates, and target integer is given. We have to return a list of all unique combinations of candidate, where the chosen numbers sum to a target, and you may return the combinations in any order. The same number may be chosen from candidates unlimited number of times, and two combinations are unique if the frequency of at least one of the chosen numbers is different. It's guaranteed that number of unique combinations that sum up to a target is less than 150 combinations for that given. Okay, so like a target is given, an array is given to you, so these are the two possible arrays. I mean, array of elements whose sum is equal to the target, and you can use any element any number of times. So 2 to 4, and if you use one more to 6, then you won't be left with one, right? So it's like, let me just for a sec. Let me. It's. I think we have done this ample amount of times. So 7 is our target, right? If we take 2, then our target will be 5. Then again 2, because multiple times we can use. Then again 2. But if we take 2, we'll be left with 1. But there is no possibility to get 1, right? So you'll backtrack from here, and then you'll take 3, and 2 to 3. This will be your one. What is it? I mean, one valid array, right? Or the other way, if you go via 3, then you'll be left with 4. Again 3, you'll be left with 1. Again you can't get 1, so you'll backtrack, right? And 3 with no other combination it will give you. Other is like directly 7. If you take that, you can get. So these two are the valid ones. So it's like a backtracking, like right? Try all the possibilities and check if it's possible to obtain a given sum or not. And depending on that, you can, what do you say?
Yeah.
Store that. Okay. Yes, interesting.
Yeah, it's a backtracking, that is correct. Yeah. So I don't think so we can do this any other way other than recursion and backtracking, right?
One doubt I have always, why can't we do this like coin change problem? Like target is given, right? And you have to minimum. Oh, but their minimum number comes, right? Optimization comes. That's okay.
Mm-hmm.
Coin change problem, we have no target, like how many coins will sum up to the given target.
Yeah, but here we have to return the combinations also.
Yeah, yeah.
Most of the ones what we do for those problems, if we have to do a bottom up, and if we try to use a lookup table, something like that, so in those cases we just return some value, right? So if you want to return a result of all these things, then I think, I don't know, maybe this is the better way of doing it, right? Because we
Yeah.
are combining all those candidates, sorry, yeah, the candidate,
Hmm.
and then forming different combinations, right? So you have to copy all those at the end to form a result or output,
Array.
an array also. Yeah.
Yeah.
I just a thought maybe.
Yeah, yeah, sure. Like that is what I'm doing, like what you said for backtracking approach. Yeah. Any question?
So
Or
if we are talking about of backtracking, what's the difference between simple recursion and backtracking? Yeah, I use recursion. Yeah, let me share my solution. Yeah,
sure, definitely. Let me answer. I think backtracking you do pruning part, right? Which you don't do in recursion.
but we always have base case. Yeah, in recursion.
Yeah, we have a base case, but there it's like you keep on going till the point you hit the what you say the base case, right? But in backtracking, you wisely take the decision whether should you take that branch on, right? Isn't I just my thought? Like I'm not sure that much.
Yeah. I use it recursion. Yeah, so it's also recursion. So I call helper several times. Yeah, let me explain my solution. Yeah, I created a release. It will be returned. Yeah, and I wrote a helper function. Yeah, helper function take candidates position. in this array target value, current result, yeah, and accumulator, yeah. And here I have like base case. Yeah, as for me, it's base case. If target is less or equal 0, I just check. If it's 0, I add current result to accumulator. Yeah, and then I do just basic traverse from this index up to end of array. Yeah, and call again. And is it backtracking?
Yeah, it is
It is back.
backtracking.
It is backtracking.
Yeah, but it's also recursion. Yeah, how can we have
So
recursion
you,
without backtracking?
yeah, so you're using that new current for each and every level in recursion, right? So that you don't take carry forward, right? For every recursion level, you have a new curve,
Yeah,
right?
yeah.
So you are actually, when you come back to the previous level, you just throw back the previous one, correct?
You mean
So
okay.
that is the way, a different way of doing a backtracking. Yeah.
Yeah.
By the way, I have one more solution. It's pretty similar. Yeah, just without a loop. Without a loop. Each time we can have two options.
Knapsack.
Uh,
Yeah.
Continue with this with this number, yeah, with current position, or and subtract this value, or skip this value and check. So we have always two options, yeah, and it's also backtracking here because as you say, uh, here I am add the value, but when I will return, yeah, or not.
Yeah, you are
Right.
adding new value to that. Yeah.
Yeah, this is a good one also. So you're trying to use the knapsack way.
Yeah,
Yeah.
yeah,
Either
One.
you take it or you don't take it, right? The first one on line 12, you are taking it that
yeah.
value, and the second one you aren't.
Hmm. So, yeah. I mean, one doubt doubt is like that syntax. I mean, just getting. So with that new array list, what it does, like cur is always a list. I mean, cur itself is a list, right? I mean, array list, isn't it? Line number 5.
Line number 5. Yeah, yeah. I just create. When I pass current, it's just a pointer. Yeah, it's just a
So,
pointer. And here I create new. I create copy of current element. So I create list, new array list, basic, and I pass current list. It will produce a new instance of array list.
so current is not an array.
Current
List
is
of it,
not
yes, it is, right? Current.
did not catch current. It's the first time it's empty. Yeah, the first time current is empty. When I call this function helper first time, yeah, I will create one more list each time, yeah, and I will just copy everything from previous list and create new list and then add the current value to that new list.
Yeah, but Nick, one thing, you are creating on line 10, you're always creating a list again and again.
Yeah,
So is
yeah.
that not an expensive operation?
Yes, expensive, but in this case, I do not need to remove value from the list. Yeah, I do the same here. Otherwise, I would have to do something like remove, yeah, remove
Yeah,
here.
you will have to remove that. So that is what happens, if you do it, because what would happen every time you append just your current, whatever you take it from the parameter,
Yeah,
correct, and then just add that value instead of creating another array or list, right? So then what happens? You're not creating the whole, copying the whole array again and adding another value. So that might add to your time complexity, right?
yeah, I agree. But even in this case, this means this is backtracking as well. Yeah,
Yeah, it is backtracking. So because you are not considering no for the next level. So for each level, everything is different. and then you're going back to the previous state. So backtracking means that you want to go back to your previous state when you are done with the current level of recursion, or we have to move forward, so you have to add something more to your state, right? So that particular level, you will always have a different state values.
Yeah, but as example, when we do pre-order traverse in tree, does it mean that we use backtracking as well? Pre-order traverse when we use recursion.
It depends on how we are implementing, correct?
Okay.
It's comparing with the tree, like, I mean, where first we take a root and then go to the left and right.
Thank you.
Yeah, that's good. Yeah, thank you.
Yeah, it's same like what Nick said, same thing it is. So like you are passing back tracking function, and this array is the target function, and this will store your intermediate states and initial start index. I mean, this is 0, right? And if it is less than 0, target is equal to 0, then you just append that path. Otherwise, if you have you take that number and subtract it from your target and add that to the temporary list, and then go for it. Since we are keeping, because same number can be used multiple times. So rest.
Yeah. So what will be the time complexity in this case? So is it going to be
n into 2 raised to the power n? No, because for loop is there, and either you can take that element or you can't take that element in this, right?
Yeah, so the Nick showed about using knapsack way, correct? So is that not exponential 2 raised to n in that case?
Your next will be exponential on like knapsack way, which you were saying, right? Either you can take or you can't take, isn't it?
Yeah, but both time complexity should be same, I think.
Yeah,
Isn't
both
it?
will be exponential, yeah. And n will be
So
a
yours,
factor of
this one is also going to be the same, correct?
n into 2 raised to power n, yeah.
N
But they
into,
have yeah, go ahead.
no, you said n into 2 raised to power n.
Because yeah, I saw somewhere in the solution they were describing with the help of a tree's height.
Yeah, so they say that n into 2, not 2 actually, the target, n raised to target divided by that smallest minimum element in the array. So target in this case is 7.
7, yeah.
Yeah, and our minimum element value in candidate is 2. So 7 divided by 2. So it will be 2, 3, the 6. So n is,
That is height of tree, right? And
yeah, something like
target.
that.
Yeah.
So it might be 4, n raised to 4. Yeah, but that is not the way the time complexity should be.
Yeah, I
Right, so
think
it should be exponential then in that case, correct?
looks like that, yeah. But they are taking minimum value and dividing the target to get to check till what extent the length of the DFS tree will go. And at every level, they will calculate the number of nodes will be constant. So number of nodes into the height that you will get. So it is n into 2 raised to the power target something. What is that exactly?
N into the t, which will be the target, divided by the minimum element in that array. So
Yeah,
n raised to 7 by, in this case, the first example, it will be n into 7, n raised to 7 by 2.
like this.
No. N 7 by 2.
Oh,
Let me do it.
7 by 2.
Right. So it will be n into raised to 7 by 2, something like this.
Okay, on the top of it.
Right. So this 7 by 2 in this case will be, we can approximate to 4, correct?
N cube. Oh, yeah, 4 also.
Yeah, because one more, there would be one more layer, if we do it that way. So yeah, because we still, if we go pick this 2 element, yeah, this is going to be the height of the tree. So if you still pick the 2 element, in that case, you will go down, correct, all the way. So the last one, even though it is going to return a negative value, you'll still have that length, correct?
Yeah.
So here, even if you have 1, something like that, and then you come here, it is still going to be -1, but you still come one recursion down, and then you return from here.
That
So that
point, yes.
will be counted as one level. So it will be a 4. So therefore n raised to 4. But then it is going to be always different for the based on the test case, correct? So
Yeah, that's
therefore
why
that is not the right way to calculate the time complexity.
yeah. So basically, they are calculating the height. Target by minimum number will give the height. And I don't understand why n raised to the power height they are taking.
N raised to power
Height.
height of
Height
the
only.
tree, right?
Yeah.
Yeah.
So what is that logic? N raised to the power height. I thought n into height will work, but n raised to the power they are taking.
So it for a DFS, right? If we go visit each and every node, so that will be our time complexity, in a DFS. So it is like that. It's an N array DFS because you will have a for loop, right? So in this for loop, so if this is for 2, so you will start another for 3, right? So
Yeah.
then in this case, you will have another for loop for 6. So this is almost like an N array DFS, N array tree DFS traversal. So for that, you will always have whatever the nodes you visit. So that will be your time complexity, right?
Yeah.
So therefore, if you look at this one, n into raised to 4 actually gives you all the number of nodes. What you can actually construct from this one.
Given tree. Yeah.
Right. So therefore, that is what one way they talk about time complexity, but I don't think so anything is mentioned other than that.
Because generally we calculate time complexity of tree based is like whatever the height of the whatever the height of the let's say height of the tree is at, and at each level what is the number of nodes you are seeing. I mean, number of nodes in array will always be n, right? So it is constant at each level. So n into whatever the height of a tree, that is the time required to move an element from bottom to the top. So that's why I thought n into h.
Yeah, but in this case, it's not a binary tree. So therefore, there 4 is to n is fine, right? But here it is an array. So all the elements in your candidates will be in that for loop, right? So there will be that many branches. So therefore, n will be the number of candidates. So the size of the candidates.
Candidate to the power of height, right?
To the power of height of the tree.
Yes. Okay.
So that will be still. So it's not going to be n square for sure. Yeah, it might be in some cases. Correct.
No, if let's say target is 7 and element minimum element itself is 7. So n 7 by
Right.
7 is
Yeah, in that case, it might be 1 or 2. It is again variable.
yeah.
But then if we want to generalize it, can we say it's if something, whenever we say n raised to something, power of something, and if it's greater than 2, 3, 4, and if it is almost like n raised to n in some cases. So
That's
do
n.
we say it's a factorial then?
Yeah. N raised to power n is again n factorial, almost
Right.
like upper bound. Yeah.
Yeah. But if we say that, that is will also not be the right thing, correct, in this case. It's not
Yeah.
justifiable, no?
Mm.
I don't know, yeah, but this is what
Yeah.
it says. So it is very confusing. In some cases, they don't even talk about that. They just talk about the length of this candidate array multiplied by the size of the height of tree. So
True.
that is also some people talk about.
And what about this? And target is 7 and you got a number 0 here, right? Minimum. So n raised to power infinity it will go, right? It will never end. That
And this to power. Yeah, that makes sense.
it
Absolutely.
will become nonsense. I mean, the algorithm will never terminate, right?
Yeah, in that case, anyway, see, if
Maybe
you come to 0,
this is not
uh,
defined
no, if you
anything.
come to 0, yeah, see, n raised to, anyway, we are not doing this calculation, right? It's just for getting a time complexity. But if you look for implementation, when we get to 0, it's useless for us. We just return back from the same level almost, correct? because it
Then
will be 0 minus 7 will be minus 7, and then you'll return back immediately from one level tree. Yeah, but as per the time complexity, it's just on paper you are calculating, correct?
yeah.
So
So these
even if
things
it is infinity, we can take care of that.
uh, then go into NP hard problems and like what do you say? They're like again state machines and all those things will happen, right? Because those problems will not be solvable by system, isn't it?
Yeah, I don't know whether this problem is of that complexity.
I'm just thinking like NPC,
No,
NPH.
yeah,
So
that's correct. That's true. Just yeah, go ahead. Yeah.
sure, sure. So next is encoding.
Yeah. I'll just come back. Just give me a
Sure,
minute.
sure. Definitely. Take it. Yeah, in the meanwhile, I'll just read the question. Yeah. So this is like encoding and decoding the tiny URL. This is a companion problem to the system design. Okay, design tiny URL. So they have given the definition like it is a URL shortening service where you enter a URL such as this, and it will return a short URL like this. Okay, web crawler system. Yeah. Then design the encode and decode methods for the tiny URL service, and there is no restriction on how your encode decode algorithm should work. You just need to ensure that a URL can be encoded to a tiny URL, and tiny URL can be decoded to the original URL. Hmm. Yeah. So what do you think? This is like, I mean, a couple of days back we were having web crawler system design, right? That lecture. There, like we were passing the big URL, and then it used to go to the HTML content parser, and then what you say, back and
Yeah.
front end. Yeah, there. Yeah, yeah. Nick is there. Yeah. Go ahead.
Yeah, and we also saw that there is a tiny URL, yeah, system design question, yeah. It's
Exactly. Yes.
yeah,
And
so yeah, please go ahead.
I'm saying I miss that back queue and front queue used to be there. What, like, you used to use many priority queues, right? Like you used to give priority to the most important URL, and then you used to pass it to the front queue.
Yeah.
Isn't it? Do you remember the high level design? I've been, I mean, if I recall, I'm not able to, I mean, I couldn't retain that much. So can you, yeah, go ahead. Like,
There is something, and when I started to think about simple approach just to number each URL, which is so I just number all URLs. I receive URLs. I have a counter. I put counter to map, yeah, and so I use map to solve this task. The map has integers to string.
can you annotate? Like, so what you are saying, are you calculating the number of characters in the URL and then correspond, I mean, that will
Yeah,
act as,
yeah. Not number counter. I thought like in real example, I just wanted to have a service which provide for me unique integer for each incoming URL.
or unique integer for each given URL, right?
Yeah. For each given URL, I just use counter, yeah, which I increase each time. So when first URL came to me, it will be first URL, then
Hmm.
second, and etc. And I just populate a map. It's one of way. Yes, there are a lot of way how to solve it, and I found that this one is more easy for me.
Yeah, but
Can
that
Yes.
you won't use in
so
a real design, correct?
design, yeah.
Because that
Yeah.
will
So
be a highly predictable one.
Can't we use random
so
number for generating the unique numbers for each URL? Like Nick was using counters, right? And there in the lectures we were having day for yesterday, there I think also they just said like some unique number ID generator it will give, but there was not much discussion, right, regarding that number generation, right? I mean,
Yeah,
yeah.
in case of
So
unique
the
number, we just need to check that we have not used it before. Yeah.
You want to share, like, Nick?
My simple, just unique
Yeah, no
count.
problem. Let's go.
Okay, okay, let me share. Oops, just 1 second. Okay, not sure this one. Oops. No, not this one. Sorry.
Yeah.
Okay, what is it?
Problem is your, what is the number?
Let us look at it. Okay, this one. Sorry. So I use a counter. Yeah, I define a counter, and each time when your URL is arrived, I just increase counter and um, put key. In case of get key function, I just run
Yeah,
can convert to string. Yeah.
correct.
So I
So this
put
is a very
command.
basic way of doing it, correct, Nick?
Yeah.
Yeah.
Yes, very basic.
Yeah, but this
Every,
won't fly in the interview. Really, it's a medium problem, correct?
Yeah.
yeah.
So there will be a lot of questions coming up on that. So it's good actually. You have a map of a string to string conversion,
Yeah.
right? You are actually trying to mapping, but when it comes to a question like a tiny URL and in the system design also to some extent, at least we would have to consider one aspect of it, like it should not be highly predictable one, correct?
Yeah, I agree. Yeah.
Yeah.
Of course.
So that
What
would
about,
work. So what I think Shashank was saying about the random one, that
yeah.
might work, right?
So,
So this is
but
good. Actually, the Leetcode accepts it because they don't check anything about how your tiny URL is being created.
Yeah.
Yeah,
In case of
in Leetcode, if we direct return the long URL and the short URL, even that gives an accepted solution.
Yeah. So they don't verify actually the answer
Yeah.
there.
yeah,
So the
Especially for
only problem, so some of the problems which we face if we use the counter approach is, since we are using numbers, uh, we can we have limited amount of numbers which we can choose from. Even the size of the map, since the map can store a limited amount of uh, numbers, so at at an instant when there will be too many URLs already sorted, then we cannot store further URL again in the map. So that can be one of the problem faced if we use count method. Again, the since the count is incremented linearly, that is from +1 +1 for each of the new URLs, it is highly predictable that we can check if any URL exists or not. Right?
and
That can be one of the problems.
integer
And
overflow
again,
would be there.
we, uh, we cannot use custom URLs like in some of the TinyURL service. We can define the sort code uh, which we want, but here since it is hard coded, so the URL always will not be custom one as per the user requirement.
but we are not concerned about the custom URLs here, right?
They
Are
give you
we?
Yeah,
wrong
yeah, yeah.
interpretation.
Yeah, but
No, no,
that
no.
is one good way to think about it. But for this
Yeah,
problem, yeah, but I think the way you said, because if you use a map and integer, so we have limited number of URLs also, right?
yeah,
So
yeah,
that might be one thing. So string to string mapping will be much better, at least for a map.
yeah.
And this
Okay.
count won't
And
get
we,
like, go ahead.
since we are using only numbers, we only have limited supply of numbers which we can choose from.
Mhm.
So if we use a integer here, then after the range 2 to the power 32, it will overflow. So it will give us a negative index, and then once it gets back to positive index, there will be collisions. So two URLs will be mapped to one index in the map. So that can be one issue here if
Mhm.
count is used.
Yeah, that is right. But if you think in terms of collations, and if you start using all those other cryptographic, whatever those hash algorithms, correct? So that might be too much for this problem,
Hmm.
Yeah.
right? Yeah, because I think
Even
there is one video from Tushar Roy, he uses that, right?
Like,
yeah, even if we use cryptographic hash function here,
Uh-huh.
the length of any of the secured cryptographic hash functions are pretty huge. For example, if we use the secure hashing algorithm, the most secured one, the recent most secured one is the SHA-2 family, and SHA-256 is the most commonly used one, and its length is almost 64 bits in hexadecimal equivalent and 256 bits long in binary equivalent. So uh, again, it will take too much of space in our map.
Right, right, right.
even MDH we use, is it?
MD5, no?
MD5 here, MDH and that's
So
MD5.
Bloom filter also is for the same thing, right? They provide uniform, unique hashes. Is it?
Bloom Bloom filter is basically for, let's say, where hash map is like large billions of data is there, and you want to search a given username, password,
Okay,
something
okay.
like
More like a
for that.
storage thing, right? Here we are trying to encode.
Encode. Yeah,
Yeah, it
bit.
is, I guess, used in Facebook for caching purpose.
Yeah.
Uh,
So
Yeah.
Bloom filters are
caching.
used generally for caching. Like if a search is done in Facebook repeated times, then Facebook tries to store that particular search history inside our browser, so that it do not have to do not have to fetch the page again and again.
Hmm.
That is the
Right.
cookie thing, no?
Okay.
Yeah,
Right.
yeah, but I read it somewhere that Facebook uses this Bloom filters for caching purpose.
Okay.
Okay. So coming to our question, if we want to use a reasonable version instead of going through the cryptographic hash function and all that, so what is a better way of doing? Because if you use integers, that will be more predictable. One way would be use a random number, as Shashank was saying, correct?
Yeah, or letters and digits both you combine. Like it looks like what
Yeah,
you.
so that would be one better way of doing it. That is what I actually, yeah. So if you use letter and digit and then combine them, so you can form a much better this
Oh,
tiny URL, right? It will
in that,
be,
yeah, go ahead.
yeah, go ahead. So what is this one?
Yeah, same thing. What you are saying, letter set, like I mean, letters plus digits you combine, right? And
Uh-huh.
whatever length you have, in that you again do the random choice.
Okay. So what are these ASCII letters
ASCII
in
letters,
string?
both small plus capital plus, yeah, small plus capital only, I think.
Okay.
Yeah.
So along with your digits, so that becomes almost 26 plus 26, right? And then digits
Plus,
will be your 0 to 9.
56, 9, 52, 9,
So 62 almost, right? Yeah. Okay. I think that is what, there is one solution in, okay. So then you go and make this one encoded. Okay. Why don't you walk through this problem then? Sorry, this implementation.
So I've taken two map, right? One code to URL, other URL to code. This is a dictionary.
Uh-huh.
And this is the encoding scheme what we are using. Like letter set is created using your ASCII letters, I mean, small capital plus digits. And as long as like long URL is not in our URL to code, that means first time you are seeing, right?
Uh-huh.
So what do, you generate random numbers out of this. I mean, out of this letter set, you check, get any random one, right? For the given range of 6 by 6, I think it mentioned somewhere. I'm not
Okay.
sure
So,
what is
Yeah,
so
6.
so
they
they
are
have set the length as 6.
Oh, they mentioned
right.
somewhere.
No, no. Actually, they were just
No, no,
taking
no.
for
We
six
can take
tiny URL.
anything. Yeah.
Okay, okay. Yeah, after that, it's like if the
No, I didn't
code is,
get it. Why six? What is six doing here?
That will be
usually
a very small number, right? See, if you look at the example on the description, he says that TinyURL and 4E9IAK. So that is about 6 digits, no? So if you use 6 digits,
Okay.
and then you form, you can form many URLs with different combination from 62 characters.
Okay, got it. So this random dot choice will pick one letter at a time, right? And that we are doing 6 times.
Right.
Cool.
6 times in the sense like I didn't get like 6 times.
So you'll have your output TinyURL having 6 characters. So the
Yeah,
way it
6.
is in 4E9IAK, that is 6 length, right?
6 then, yeah. But that is you told
Yeah,
6
so-
times, right?
Sorry?
That is what you told 6 times, right? I thought that any like you complete your like I mean.
No. So this code thing, which you are putting in your line number 13, would be
Yeah.
a 6th length character.
Yeah, that's true.
Correct. Okay.
I
so,
thought multiple sufflinks we are doing 6 times. That's what I had a perception. Like, I mean, multiple 6 times sufflinks you will do, and then out of that, what you get, that would be taken as a number. But 6 here actually stands for the length, that slash 49IK. What you do, I mean, which
yeah,
told.
you can take more than 6 also. That's not a question.
Okay.
You know, it depends on how much URLs you want to support. Right. So usually the system design, we do those calculations, right? How much, what is the input based on a requirement. So, but we are
Envelope.
assuming that 6 should be sufficient for us in our case, right? So therefore we are taking 6. That's okay. Okay. So one thing, when you are in this while loop, okay, you are doing a code, whatever the code you form with random number generation. So then you try to look if that code is already present
Present on
in your
yes,
code to URL, right? Okay.
yes.
If it is not present, you push in that. Okay. But should it not that you should terminate from this one now? From this while
Sorry,
loop?
what was your point,
Line
Santosh?
9 will take line 9 will already check that condition.
Okay. So long URL is present or not.
As long it is not present, you'll check whether that code is in the code to URL. And if it is not, once it will do and will come out right next time. If it is there, then automatically it will come out of that while loop, isn't it? I mean, if we already got the code for it, then we won't be doing next time inside the while loop. And
So why
directly-
is it why is it not if?
Because multiple times, like if you don't have, right, what do you say? Like multiple times you have to check that, isn't it?
Why
Yeah.
multiple times? Once you generate the hash, just put it in your both these code to URL and URL to code, and then you can return.
No,
Is it?
he is trying to check if that is already used. There might be a possibility, whatever the random URL what is generated, a tiny URL what is generated by this random choice, it might already be in his map, right?
Assigned to somebody, some other
Yeah.
URL.
So therefore he's checking. That is correct. So, but yeah,
So this
Abhishek, how
tiny
do
URL is generated on line number 10, right? So this long URL is the original URL.
Input,
Right.
yeah.
So my question is, why is it while? I mean, I don't think we are looping through this condition.
Why?
Should
No,
it?
let's say you generated some number out of this 6 number, right? And you have already assigned to some other URL, right? Then you can't
Okay.
assign same thing to this URL, right? So as long as uniqueness is not there, you'll keep on doing that.
Okay.
Look at the high level design of URL, like isn't it, Santosh, that
right? You should actually check, because it might so happen that whatever the random number, whatever we generated for URL, you might have already assigned to some other website. So you don't want to assign the same URL to a new one. Correct. So then it will be a mismatch, correct? Or else you are actually diverting your traffic to someone else, which is not the right case. So you'll always do a check in case if you are dealing with billions and billions of URLs, right? So then we'll arrive at that situation. But I think Leetcode even doesn't check all those stuff. because the resources might not be that efficient or sufficient for them. Even
This is
without that also it will pass, I would say. Yeah,
yeah.
yeah.
And that's why they are mentioned as a note, like a companion problem to the TinyURL.
Right, yeah. So this is good way of doing it. I think so we should do it this way. At least we should express this in an interview. But one thing I didn't
So
understand. Sorry, yeah, go ahead.
yeah, so this long URL would be the value in this URL to code, right?
Hmm.
Right. So let's say this long URL comes to us and we generate this code and you put this, you do this line number 12 and 13 thing. Okay. So now let's say another long URL comes. Okay.
Yeah.
And that is different from what came before. Now you generate a code for this. So what you're saying is that this code can be something which has already been generated
assigned
before,
to previous,
right?
to somebody else. Yes, yes, that should.
Okay. So what do you do next? So you do this thing again, right?
Keep on doing. It will always check
so
here, like has that code been assigned to. That's why we are doing this. No, this will always check. Like let's say you generated this code, right, and you marked like I mean to this URL this code has been given. Now next URL came, right, and you got this code, and it will check corresponding to this code you have this URL, right. So you can't take this. So again you will, I mean, what do you say, regenerate.
wait. Even before that, you will not come in this line number 12, right? Because this code would always be there.
I mean,
On line number 11.
11, yes.
Because so this code would always be there, right?
Oh, yes. So you are saying there is no need of while loop, right? Because code itself will check it at that point whether it has been already assigned or not.
No, there is a need. There is a need because you have to do the same thing again. So you have to repeat your line number 10.
10, okay.
So for that you go back.
Go ahead.
Yeah, so yeah, now I get it. So basically, if it is already there, then you go back in your this line number 9. Okay, then you generate this code again. You get some other blah random code, and then you just hope that this code is not there in your code to URL. Okay, so then you do this thing on line number 13. So when you do this thing, you have put this key in your URL to code, and that is where this line number 9 condition becomes false. So then you are done.
Done out. Once uniqueness is done, you will be out of the loop, right?
Yeah.
I mean, correct.
Right.
Yeah.
Uniqueness as in, yeah, once you have inserted this long URL in the key of your URL to code, you are done.
Yes. Yeah, and then this is like the format what you have to return. TinyURL plus whatever the corresponding code you have. I mean, this code.
Yeah.
And decoding is the via reverse way. Like you take, like from back you take last 6 characters and just check it in the map code to URL and return that. Yeah. So any queries here?
Decode is the very simple one to do, right? Okay.
Yeah.
Okay. So in case if you don't find that in a decode, if you don't find the short URL, so what are you going to do?
If you don't, for only the encoded, okay, that yours also is true. Like, I mean,
yeah,
yeah, that's a good use case. But I think they must be like doing first encode, then decode.
Then decode, yeah. That also
for
makes
the given
sense.
Then you return your null, right? One more, something. Like
yeah, I'm returning blank, just. But even if you don't do anything, if you just return the way you're doing it, it works.
But for real,
but this is not right. You should always check for the null case.
Null. Your real is true. Like, I mean, for real world, yours will work. Like if there is no encoded version, encoded version of it, then you return blank. Otherwise, return this. I should have checked here itself.
Yeah, that's fine. See, one more thing, when we have this now 62 characters, and then we are taking 6 characters only out of that 62. So how many combinations can we make? So how is the time complexity in this case now, if you want to just think loud about
So
the
what
time
62 are you
problem.
talking about?
So he's
62 up,
taking those 62 elements, right? Then letter set.
52 plus 9, 61.
No, 0 also will be there.
Okay, okay, 10, yeah, 10,
So that
62.
will be 62.
So for each of the character, we have 62 possible uh, characters
Yep.
to choose from. So this is why 66 raised to the power 62. Now,
Right. It won't be this 61C6, Shashank.
yeah.
No, no, 6 possible combinations you are choosing out of 62. No.
No, no,
No,
no,
but you
no,
can have
no.
repetitions also, right? So think of it like you have 6 blanks. Okay.
Mhm.
And for every
And
blank, you have 61 options.
Yeah, 61 raised to 62.
Yeah.
62 raised to 6.
Yeah. So I think 6 raised to 62 is the
Time
so
complexity.
much number of URLs we can support.
Yeah.
Okay.
61 raised to 6. No, why 6 raised to 62?
This is 10. This is 10. 0 to 9.
No, no, that is okay. 62 or 61. It should be 61, 62 raised to the power 6.
no, for
Yeah.
No.
six characters, we have 62 options to choose from. So for each character, we have 62 options. So for
Yeah.
6
Right.
characters, we will have 62 into 62 into,
That's what I'm saying. This only.
yeah,
62
yeah,
parts to power 6.
yes, yes.
So what do we do for subsequences? We have to choose, like we can either uh, skip or take. So every option has 2 options, right? So 2 to the power n we do.
So one thing just before that. So are you saying 62 multiplied by 6?
No, no, it's wrong.
No,
It's
I'm
wrong.
saying this
Because
only.
once you use this character, there will be 61 options only. Here 60 options and here 59
No.
No, no,
options.
No, you
repetition
can
is
repeat
allowed.
it.
Yeah,
Repeat
no,
it.
No, how
Please.
can you say that?
where repetition? 49 AIK. There is no repetition. They are
No,
mentioned.
if you see in the random choice, you don't
Code.
actually restrict, correct?
Right.
Okay.
Do you restrict?
Okay.
You are fine
Definitely.
with getting that. That's okay. So even if you get a URL of the same characters, no problem.
Yeah, no, I thought that uniqueness is there. Okay. Yeah, makes sense. Because within a one URL, there can be repetition. Unique doesn't matter, right?
Yeah, the random choice won't return for sure. It will try, at least for if the range is only 6. If it was a bigger range, then you will see some duplicates. But that is not an issue, right? So we can have that. That's fine. As long
Yeah.
as 2 URLs which are subsequently generated don't have a similar predictable pattern, then it is okay,
In that case, yes.
right?
Yeah.
So we say like, is it going to be 6 raised to 62 combinations or what? What we want?
62 raised to the power 6, right?
Right.
Yeah, yeah, yeah.
62,
Because for every
62 raised
possible
to
option, you
power.
have 60. Every blank you have 62 possibilities, and there are 6 such blanks. So this can be
Okay.
filled 62 ways, 62 ways, 62 ways, and so on and so forth. So 62 into 62 into 6 times, which will be
Okay.
62
So it will be around 56 billion. Okay.
billion. Right? So what is the how will you say in interview? Like, is this the number
Oh,
or like in n power? How will you say like number of m raised to the power length of URL, right? Not URL, length of this code.
well, actually, these are some of the things which are very few of them. So it is better to do a homework before working there. That's the only way, or take help from the interviewer if he has a calculator or so.
We
What
can
else you can do? Because these are very complex number, right? You cannot actually do it on your own there.
in 10 power 6 we can say 6 into 6 e power 6 into 10 to power 6.
Yeah, something like that. But yeah, 62 raised to 6, then you can, okay, either make it convert to 100 raised to 6 to some extent. That might work. I don't know.
Won't it cross 10 k power 8?
It comes to around 56 billion. So it is 56 into 10 raised to 9.
Because I thought it will hit yearly after that. It's not.
No, this is only for generating the numbers, right? That the random choice is doing. We are not consuming any time there. Is it not? It's nothing to do with the time
Yes.
complexity.
Yeah, so line 9 to 13, if you look closely there, uh, the possible chances that the code is already used cannot be more than 2 or 3, I guess. So this is why the time complexity will be constant, I guess, and not linear or exponential here.
Yeah.
Because the total number of codes which we can generate for length 6 is pretty huge. Now, the probability of colliding with the same code again in line 11, 10 is even if half of the all the codes are used, then the probability will be 1/2. So this means that out of two possible cases where we generate the code, one of the code is never being used. So this is why at max this line 9 to 13 will be repeated 2 or 3 times only. So this won't be so this is why it can be taken as constant time operation here.
Yeah. Or maximum, maybe if you think about it, it's going to be that whatever is generating 6 characters, if it keeps on repeating for 6,
Yeah. So we can take the length
it will
of
be
the
constant. Yeah.
length of the code as the complexity here.
Yeah.
Yeah, I think this is the best implementation what we can do, correct? At least for very reasonable. We don't go the system design way where we take for other things, right?
I think you
Yeah.
can add special characters also, right? Here,
What
this
was that?
place. Special characters, like you added
Yeah.
letters, you added
Mm.
digits. Here, special characters you can add.
Yeah, you can increase that, but this is reasonable because if you look at it now, we are dealing with 56 billion URLs. That is very sufficient, at least for some applications, correct?
Yeah.
It's a huge number.
Makes
And
sense.
even we are not using so for if the long URL is repeated, we are already checking in line 9 that that long URL is present or not. So
Mm.
it is not generating another sort code for that long URL.
Yeah.
So there is no issues of duplicates again. But for the count implementation, if if someone tries to spam the sort URL service and the same URL is sorted again and again, then each time it will be given new link. So uh, so if someone spams it, then it might happen that all the sort codes have been taken. But in this implementation, this is not the case since we are already checking if the long URL is already present in our map or not.
Yeah, this is
Yeah.
a very important point, correct. So this also we are taking care over here. Hmm.
Yeah.
That's good. Yeah, so we have solved that URL with most of the reasonable,
Yeah.
in
Yesterday
the
in
most
theory and
reasonable
today
way, right? Yeah.
in
But to
practical.
start with the count is always a better way of doing it, but it will surely be just to, you know, start with some discussions, right? But that won't be appreciated, so we'll have to go this way.
Exactly.
Yeah. Okay.
Yeah.
Cool.
Then we can go next. So next is binary number with alternating bits. You are given a positive integer, check whether it has alternating bits, namely two adjacent bits will have different values. Okay, like 5 representation is 101, right? So alternate bits is like 8421. Yeah, it's true. For 7 it will be 111, so it's false, and for 11 it will be 8421, right? 1011. So again it's repeated. 11 is repeated. Okay, 1011. Then it's should be true. Okay, yeah.
Yeah,
So
this
So
is
for
very
example,
simple.
in
that means if the and of these operations is zero, no, won't. I thought that. Okay. Yeah, go ahead, Vish.
yeah, so
So,
for example, in Python, we can do is first we generate the binary equivalent of the given number, and since it will be of the form string, so we just have to iterate through the string and compare the adjacent two characters. If at an instant the two adjacent characters are same, we can just return false, and otherwise at last we can just return true.
So you are saying convert the integer into a bit form,
String.
correct? In a string, okay.
Yeah. And
But
then
how do you convert that into, okay.
yeah, for in Python we have direct bin implementation, bin function, and in C++ we can use bit set.
Okay, yeah, but okay, no problem, yeah. And then you are convert that into bits, you are saying.
Yeah.
Okay.
Since in the binary representation everything will be zeros and ones, so we just have to compare uh, the adjacent characters in the string.
Okay, yeah. So
Yeah,
what
so
are you doing? Yeah, go ahead.
yeah, so the other one could be like you find the leftmost one, okay, and then basically the number is between this leftmost one and uh, between the rightmost digit, right? So now you take XOR with two numbers. One of them would be 101010, and the other should be 01010. So if you get all ones in any of the two cases, then basically you can say that the original number had alternating bits.
XOR with, so you are taking this original number, which is n, and then you are
Yeah.
XORing with what?
Yeah, so make any number, Shashank. I am on my phone. I don't think that's an option.
Okay, yeah.
Yeah, let's take 5101.
Yeah, just write down any number 101010.
And then
Yeah,
you
add
okay.
more. Yeah.
Okay.
Yeah, so what I'm doing is now, right, that's enough. So now just below it, write 01011010.
Reversing. Okay. Other way. Okay. Alter, flipping the bits.
Yeah, so if you take a XOR with these two numbers, you get all ones.
But that could be the case where,
So
like,
I mean,
even
this can be used as a.
I don't think so. It's a sure check, is it? It could be. I mean, it will pass some
So
of the cases.
there can be two cases, right? Yeah, right. So it can be two cases. Either this case or the number could be like 010. Just the other way of what you have taken as the input.
The reverse. I mean, this one you are saying.
Yeah, so you say if you
this
add
one,
one
right.
to this number, whatever you get, if it is 0, it means it is true, correct? And if you add 1 and if you don't get it 0, it means it is false.
What add? I didn't get the add part.
So now you're see in this case, the number what Shashank has chosen is that it should return true, correct? So now you are XORing with 0101, which is that alternate 1010, right? So if you XOR with that, and if you get an output as 1, so all ones, right? So instead of checking all ones, if you just add 1 to this, okay, so you will get another 1 at the time. Okay, sorry. So then you'll have to check the power of 2 in that case. Okay.
Yeah, but I think you are actually some. This can give false positive also. So what if the number is exactly like 01010?
I mean, let's take 0011.
Right. So yeah, you can do two things, right? You XOR with this one and you XOR with the above one. So if you get 1 in either of the two answers, you can say that you had alternating bits, right?
Yeah.
You could do something like, take this number, whatever your number is, and shift it to right by 1 bit. Okay. And then you add the one number which was shifted with the original number, and then you add that with whatever that combination was with 1.
Can you annotate like? I mean,
And then just check if it is power of 2.
Power of 2, or you can make it 0 also. Check for 0. So something
I
like
did
this
not
you-
go. Could you please explain? I didn't get. Yeah, and as I understand, use shift. Yeah, do one step shift. Okay, and then
Yeah, so if this was n was something like you can take some example 7, right? And then if I say my number m, which will be something like you shift this n, right, by 1 to your
okay.
right. So if you shift this 1, it is going to be
3.
uh, 3, right?
3.
Yeah.
7 by 2 raised to power.
Right. So now if you add 7 plus 3, which will be
10.
10, right? So m plus n. So m plus n. Okay. So this will be 1. So this will be 10, right? And then you add this with the same number,
Plus 1.
right? So plus 1, right? Yeah. So
What
then
is
this
the
will be less.
logic here? Like,
Yeah,
Yeah.
I'll just show. And then if this is equal to 0, now in this case 1010 will be like this 1010 and 11 will be 1011. Okay, and if you add both of them, so you will get 1010 in this case, right? So if it nullifies, right? So it means, okay, if it nullifies, if it will nullify only when this is almost complementary of each other, right? So if you have a complement, then only it is going to nullify. Right. So if you take an example of not 5, but if you take something like 5 or maybe 10, right, instead of 7, so 1010. Okay. So if you take 1010, so if you shift with one bit, it is going to be, so this is n and your m will be 0101. Okay. And now if you add both of them, you are going to get 1111, right? So these are all ones, right? And then if you take this 111 and add 1 to this number, so this will be n plus m. Okay, and if you add 1 to this number, so what you are going to get is 10000, right? So this will be m plus n plus m plus 1. So it is almost like a power of 2. But if you add this 100 with 01111, so it will actually cancel out in case if it is a power of 2. So you will get a value of 0, right? So either instead of doing that, even if you just add 1 and check if it is a power of 2, that will also work, or you can use this add operation. So if it is not like alternating one like this one, and if it is something what we chose earlier 7, in that case you won't get a value 0. In that case you will get some value, but not a 0 value. Right, in this case it was 1011, so we were getting 1010 itself, right, after adding. So it was some value, not 0 value. So if it is any value other than 0, then you can return false.
yeah.
Yeah, so this is the most optimized one for this question,
Yeah,
since all the operations will be performed in constant time error.
yeah. But I think if we have this m plus n, and when we add 1, if we just check if it is a power of 2, that also would be fine, right? But if we check power of 2, in that case, it will be another while loop to do.
But power of 2 can be checked in constant time using the same AND operation.
Yeah, that is one way. But if you are not able to recollect at that time in interview,
Yeah,
so
yeah.
then you will always go with the power of, and if it is greater than power of 2, then it will take a while loop will go for a long time, right? So
Yeah,
therefore, I think this will be the best way to do. Yeah, this will be something which we have a lot of time, then we can think over and do, right? Yeah.
Yeah.
Yeah. So, but why don't we walk through this one? What your implementation is, Shashank?
Yeah, mine is like first time I divided the number by 2 and I check the quotient and the remainder, right? Div mod gives you the quotient and remainder, and bit is your remainder. Now, as long as your n is not null, and this is checking whether it's even 0 and 1, right? So even and odd. If it is 0, so n mod 2, it gives you a bit. That means what? Bit means it will be 1, right? So in that case, you'll return false from there, right? Let's
Bit
take the
can be
number.
0 also, no?
Yeah, I was also 5 mod 2 if you do. So n will be 2 and your bit will be what you say 1, right? Bit is the remainder here. Now your n is 2. Now n mod 2. So this mod 2 you do, what it will be? This mod 2 will be 0, right? And that is not equal to bit. So it will not execute this line and it will further divide it into 2 parts. Like again, your n will be 1 and this will be 0. And now 1 mod 2. 1 mod 2 is again not equal to bit. So 1 will be divided into 1, 1 ja 1 and remainder will be 0.
So you understand what you're doing? So you're checking those two consecutive bits. If you write 5, it is 101, right?
Mm-hmm.
So can you write down 5? I'll explain through that.
101.
Yeah, so this bit is your rightmost one. Okay.
Mm-hmm.
And this n is 10, which is 2. Right. So basically, when you do this n modulo 2, you are checking whether this number is even or odd. So here that number is even. So you have checked this rightmost one and the middle 0. Right.
Yeah. But
This should never be the same. What?
N is the quotient, right? Why 100?
N is the question, right? So what is the question? Question is 2.
Okay, that is 10.
Right.
Okay, yeah.
That is 10.
Okay.
And your remainder is 1. Right. So you are checking this rightmost one and this 0. So they cannot be same. Right. So if your number is even, which is 2 here, so you'll always have a 0 at your end digit, right?
Yes,
and so if it's a 0, then the bit should be 1. Right. So that is why you are doing that. If they're equal, then you're returning false, because if they're equal, then they're basically the same, either 0 0 or 1 1. Then you break it down, so it's recursive. Now you are focusing on this 1 0. So this 1 0, you divide this by 2, so it becomes 1. The question becomes 1 and the bit becomes 0. So you do the same thing again.
Yeah, but this is very good. It's very tricky and a very smart way of doing it. But this won't be a very intuitive to come up with, correct?
See, I found this one more intuitive than what you explained, because that was
yeah.
pure
Mine
mathematical.
is at all, that is not at all going to come. But if we come with a very basic one first, right? So we need to actually, we should have a basic one, right? You know, like you take a number, if it were a C++ way, okay, and then you do a modulo of 2. So what we are trying to do is extracting the rightmost bit first, right? The very rightmost bit, and then you keep on comparing if it is alternating or not. And if it is alternating, you keep on dividing that by 2. So you go to the next bit. So that will be the very basic way to do first, correct? So yeah, this is a very good way. And,
no, it's the same, Santosh. It's the same. So what you are saying is the
thing?
iterative way, right?
Yeah,
you'll be going through all the way till you make the number 0.
Right.
So he's also doing the same thing. He's just taking 2 digits at a time. So first he takes this rightmost one and the middle 0, and then he takes this middle 0 and the leftmost one. So that is what division is doing, that div mod function is doing. That div mod function is giving me 2 bits at a time.
So n will be the division part. Okay, so when he's dividing by 2, that will be represented by n, and whatever is the modulo will be the bit. Okay.
Now
right.
Okay, then it is fine. Yeah, but yeah, because it's a Python way, so it was difficult for me to understand. Yeah. Okay.
Yeah.
So
I implemented in C++. There I used another variable previous, so it keep tracks of the previous bit, and then I just have to compare it with the current bit.
So you're doing it iteratively, I think, right?
Yeah.
Yeah. The code will be same. A while loop will be used, but I won't be using any extra function. I just need to keep track of the previous bit, and I just need to compare it with the current bit. So it is same like div mod,
Right.
but
Yeah.
we don't have to use any other function apart from modulus.
Yeah. So this
Right.
mod does all this stuff for us. Okay, that is
Yeah.
good. Okay. So it is the same implementation. Makes sense. Yeah. Yeah, but the one I was explaining, it's very difficult to come up for sure. It's not an easy one.
Yeah, I
Just
can
try to
share
understand
the
carefully.
C++ one, and they can see all the implementations there. Yeah, so the first one is by using an extra space here. For C++, I've used bitset here, and since it is mentioned that the number will be always in the range 2 to the power 32 minus 1, so I've declared a bit set of size 32. And now the total number of bits in any number will be always uh, floor of the log base 2 plus 1. So I just iterate through all the bits and compare if the adjacent bits are same or not. If at any instant they are same, then I just return false. Otherwise, I return 1 here. So this is the implementation where we are using an extra space here. Now the second one is
So one thing, Abhishek, one thing.
yeah,
So
yeah,
before you
yeah,
move
yeah.
on, this bitset function ignores all the leading zeros.
Yeah, so what bitset does is it will generate a 32-bit length string, but it is not string. It is same like integer array, but the values will be always zeros and ones. So, for example, if 5 is there, then there will be so for 5 there will be 29 zeros, and then uh, 101 will come. So
Okay,
I just need to
then should
iterate
this be
through.
false?
No, but I just iterate through the number of bits in 5. So for the number of bits in 5 will be 3.
Okay.
So
Got it.
Right.
here, yeah. So this is what we have to first consider here. Otherwise, this consecutive zeros will give false here.
Right. That is what I was wondering, because you're doing
Yeah,
this consecutive check. But yeah, you are checking for only log of n, right? So that would be 3
yeah, yeah,
or 2 in this
yeah,
case.
2.
Yeah. So you are doing 2 checks.
Yeah. Now, since it is using an extra space, we can just keep track of the previous bit here. So I've declared a previous variable with -1 for the base case. And then the current bit will be the modulus of the current number. And I just divide the current number and just compare if the current bit and the previous bit are same or not. If they are same, just return false. Uh, if they are not same, then I assign the previous bit to the current bit. And if all the iterations are performed and no consecutive adjacent characters are same or the adjacent bits are same, I just return true here. So even here we are iterating through all the bits of the given number. So to further minimize the complexity here, we can use the approach which Santosh mentioned. So I'll just share the screen here. So if this is the number, if we right shift it by 1, then the number will be this one. And if we add both the numbers here, we'll get this type of number. Again, if we add 1 to this number, we'll get a number which is always power of 2. And if we add both these numbers, we'll get a number which is 0. So this is what we have to do, and all these operations are constant time since it is bitwise operations. So uh, I first assign the right shift of the given number to A, and then add the given number itself. The reason I'm doing this in 2 steps here is because since the number is 2 raised to the power 31, when I add uh, these two numbers, that is x and x plus x right shift 1, both these numbers will go out of range for integer. So it will give me an overflow error. So this is why I have to do this in 2 steps. And now at last I just have to check if the AND of these two numbers, that is the addition of the given number and right shift 1 plus 1 is 0 or not. So not of the given numbers. So this one is the most optimized one.
So what are you doing in two steps? This line number 21 and 22.
Yeah. So if we see here x, if we add directly x plus x right shift 1, since the range of x is in the integer limit, now if x is taken as int max, and we right shift x with 1, then this number will be less than int max. But if we add something with int max, it will give a overflow. So this is why we have to do this in two steps. So either way we can do this, y plus equal to.
Okay, but anyways, if you add this x plus x right shift 1, this would be greater than integer, right? You add
Yeah.
it anyway.
Yeah.
Either you do it in 3 variables or 4 variables. So anyway, this would be greater than int max. So
Yeah.
should it not give you overflow?
Yeah, so this is why y is, I have considered the variable y as long int here.
Okay, yeah, then it is okay.
Yeah.
So was it giving you overflow if you're doing it in one place at one shot?
Yeah, it was giving me
It will,
overflow here.
yeah.
These two are the cases.
Either you use unsigned also, that should be fine. But yeah, long is good.
Yeah.
Okay. So it is exceeding long also, this int max plus
No,
int
actually, it
No,
is
max
no.
right
only
shifting.
integer,
No,
but
the
only
reason
one
I am
bit
not
it will
doing
limit.
this in one line is, in C++, this addition will be performed first, and since both these numbers are integer, when they get added, it will give me a overflow, and then it will be assigned to y.
Okay, good one.
Yeah,
So
so
you
this is
can
why
typecast this x to long and then do it,
long it.
right?
Then only I have to do this in. Then only I can do this in one line.
Right, yeah, got it.
Yeah, cool. Okay.
Yep.